Welcome back, everyone. Ready to dive deep into something truly fascinating.
Absolutely. Always up for a good exploration.
Today, we're going to unravel the mysteries of combustion.
Ooh, that's a hot topic.
It really is. It's something we encounter constantly, but rarely stop to think about.
I know, right? Like fire's just there.
Exactly. But there's a whole world of science happening behind those dancing flames.
And who doesn't love a good fire? Especially when you understand what's going on.
So let's break it down, starting with something super simple. A match.
Okay, I'm intrigued.
When you strike a match, what's happening to create that little burst of fire?
Well, you've got a few key players coming together: fuel, oxygen, and heat.
Right, the classic combustion trio.
Exactly. And when you strike the match, the friction generates enough heat to reach something called the ignition temperature.
Ah, the ignition temperature. That's the point where things get fiery.
Yep. It's the temperature at which the fuel can finally react with oxygen in the air.
Okay, that makes sense. Like when I'm trying to light a campfire and I'm struggling to get those big logs going.
You're basically trying to hit that ignition temperature, yeah.
Exactly. It's like a battle to get things hot enough. And that's why we use kindling and paper, right?
Exactly. Smaller pieces with lower ignition temperatures catch fire more easily.
So they kind of kickstart the process for the bigger logs.
They get the party started, providing the heat needed to reach those higher ignition temperatures.
I see. It's all connected. So is that why some things just won't burn no matter how hard you try?
You're thinking about combustible versus non-combustible materials.
Right, like wood burns, but a rock doesn't.
Exactly. It's all about their ignition temperatures. Things like wood and paper have relatively low ignition temperatures,
Making them easily combustible.
while materials like glass or stone have super high ignition temperatures. So under normal conditions, they just won't burn.
This is making me realize how much we rely on combustion in our daily lives. It's everywhere,
It truly is.
from cooking to heating too. Wait a minute. Isn't digestion a kind of combustion too?
Whoa, you're blowing my mind here.
We eat food, which acts as fuel, and our bodies use oxygen to break it down.
You're absolutely right. It's like a slower, more controlled form of combustion happening inside us all the time.
Our cells are like tiny little furnaces, constantly burning fuel to keep us going.
And incredibly efficient furnaces at that. Our bodies extract the maximum energy from food, leaving very little waste.
Mind-blowing. Okay, let's move on to another essential ingredient. Air. Remember that classic experiment with a candle and a glass?
Oh yeah, the one where you suffocate the flame?
Exactly. You cover the candle and the
Yeah.
flame slowly dies out. Why does that happen?
Because you're cutting off its oxygen supply.
So oxygen is crucial for combustion, which is why it's so dangerous to burn things in enclosed spaces, right?
Absolutely. Without enough oxygen, combustion can be incomplete.
And you get nasty byproducts.
Exactly. Like carbon monoxide, which is colorless, odorless, and potentially deadly.
Scary stuff. Okay, let's get a little more explosive.
Now we're talking.
We've talked about candles and campfires. Pretty tame forms of combustion.
Right.
But what about things like gas stoves or explosions or even spontaneous combustion?
Ooh, those are some intense examples.
They are. And they make me wonder, is combustion always the same? Or are there different types?
That's a brilliant question. Combustion isn't a one-size-fits-all phenomenon.
So it's more like a spectrum.
Exactly. The way combustion happens, the speed, the heat, the presence of an explosion, it all depends on the fuel, the oxygen, and the environment.
So like a calm, steady gas stove flame is a different type of combustion than, say, cooking oil suddenly bursting into flames.
You got it. The gas stove is a controlled, rapid combustion. The gas mixes with oxygen and burns quickly, creating that steady flame we use for cooking.
Okay, that makes sense. But the cooking oil thing freaks me out. Why does that happen?
That's spontaneous combustion. When oil gets dangerously hot, the heat builds up inside it, and eventually it just ignites. No external spark or flame needed.
No wonder they call it spontaneous. It's like a combustion time bomb. Okay, let's shift gears a bit and talk about the anatomy of a flame.
I love this part.
We've all stared into a candle flame, mesmerized by the flickering light and the dancing shadows. But what's actually happening in there?
More than meets the eye.
I bet. There are those distinct zones of color, the dark inner core, the bright yellow middle part, and that almost invisible blue outer layer.
Each zone represents a different stage of the combustion process and a different temperature.
Oh, interesting. So it's not just for looks.
Not at all. That dark inner core is where the wax vaporizes but hasn't started burning yet. Then you have the luminous yellow zone.
That's the part we usually associate with fire.
Right, and it gets its yellow color from glowing carbon particles released during the burning process.
Wait, so the yellow part isn't even the hottest part of the flame?
Nope. The hottest part is that almost invisible blue outer zone.
Really?
That's where complete combustion is happening, with the fuel burning most efficiently and producing the highest temperatures.
Wow. I never knew that.
And this knowledge has practical applications, too. Goldsmiths have been using this for centuries.
Wait, like those artisans with low pipes who melt gold?
Exactly. They're using that hottest part of the flame, the blue zone, to work with precious metals.
That's incredible. Science and craftsmanship coming together. Okay, this is blowing my mind.
Just wait, there's more.
We've covered the basic ingredients, the different types of combustion, and even the anatomy of a flame. But now I want to talk about something a bit more practical.
Okay, hit me with it.
Fuel efficiency. Imagine you're faced with a challenge. You need to boil water, but your only options are cow dung, coal, or LPG. Which one are you choosing, and why?
That's a tough one. But I think I'd go with LPG.
LPG it is. But why? What makes it a better choice than the other two?
Well, it all comes down to something called calorific value.
Calorific value. That sounds sciencey.
It is, but it's not as complicated as it sounds. Calorific value is basically a measure of how much heat energy is released when you burn a certain amount of fuel.
So the higher the calorific value, the more heat you get.
Exactly. And LPG has a much higher calorific value than cow dung or coal. That means it'll boil your water faster and more efficiently.
Okay, that makes sense. But why is LPG so much more efficient? What's going on at a chemical level?
It's all about the chemical composition of the fuel. LPG is mainly propane and butane, which are hydrocarbons with a very high energy density.
Energy density. So they pack a lot of punch in a small package.
Precisely. Cow dung and coal, on the other hand, have a more complex composition with lower energy density.
So it's like comparing a high-performance sports car to a clunky old truck. The sports car gets you there faster and uses less fuel because it's designed for efficiency.
You got it. And this concept of calorific value is important for more than just boiling water. Think about heating your home in the winter.
Okay, I'm following.
If you were using wood as fuel, you'd need a massive pile of logs to generate the same amount of heat as a much smaller amount of LPG.
So choosing the right fuel is about more than just convenience. It's about efficiency and cost effectiveness too.
Absolutely. But there's another crucial factor we need to consider: the environmental impact.
Right. We can't talk about combustion without addressing the elephant in the room.
Exactly. Combustion, especially the burning of fossil fuels, has a dark side.
Okay, let's talk about that. I know fossil fuels have a bad reputation when it comes to the environment. But can you break it down for me? What exactly happens when we burn them, and why is it so harmful?
When we burn fossil fuels like coal, oil, and natural gas, we release a whole bunch of harmful pollutants into the atmosphere.
Like what? Give me the rundown.
Things like carbon dioxide, carbon monoxide, sulfur dioxide, and nitrogen oxides. Not exactly the ingredients for a healthy planet.
Those are some nasty-sounding chemicals. What makes them so bad?
Well, some have a direct impact on human health, like carbon monoxide.
Oh yeah, the silent killer.
Exactly. It's colorless, odorless, and can be deadly because it interferes with our blood's ability to carry oxygen.
That's terrifying. But what about the other pollutants you mentioned?
They have more long-term, widespread impacts on the environment. Carbon dioxide, for example, is a major contributor to climate change.
Climate change is the big one.
It acts like a blanket in the atmosphere, trapping heat and causing the planet to warm up.
And that leads to all sorts of problems, right? Like rising sea levels, more extreme weather, disruptions to ecosystems.
Exactly. It's a cascade of negative consequences. And then there's acid rain.
Acid rain. That takes me back to my childhood. It was a big concern back then. How does that fit into all of this?
It's another consequence of burning fossil fuels. Sulfur dioxide and nitrogen oxides react with water vapor in the atmosphere, forming acids.
And those acids come back down to Earth in the form of rain, snow, or fog.
Right. And that acidic precipitation can harm plants, animals, and even buildings.
It's like a domino effect of negative consequences, all stemming from our dependence on fossil fuels. It's pretty overwhelming, to be honest. Is there any hope for a cleaner future?
Absolutely. We can't eliminate combustion overnight, but we can definitely shift towards cleaner, more sustainable fuels.
Give me some good news. What are our options?
One promising alternative is CNG, or compressed natural gas.
I've seen more and more CNG vehicles on the road lately. What makes it a better choice?
It's still a fossil fuel, but it burns much more cleanly than gasoline or diesel.
So fewer harmful emissions.
Significantly fewer. It produces less carbon dioxide and almost no particulate matter, which is great for air quality.
So it's a step in the right direction. That's encouraging.
It is, and it shows that we have options. We're not stuck with the dirty fuels of the past.
It's good to hear. Looking back at everything we've discussed, the basics of combustion, the different types, the environmental impacts, the potential solutions, it's clear that combustion is a powerful force that shapes our world. It's a force we need to respect and understand, especially if we want to use it responsibly.
Right. It's not just about knowing how to light a match or start a fire. It's about recognizing the impact of our choices.
Exactly. So as we wrap up this deep dive into combustion, what are the key takeaways you want our listeners to remember?
Well, first and foremost, combustion is fundamental. It's been a driving force in human progress for millennia.
It's hard to imagine our world without it.
From those early campfires to the engines that power our modern lives, combustion has shaped everything.
It's given us warmth, cooked our food, and allowed us to travel the world.
It's truly remarkable. But with this incredible power comes responsibility.
Like Spider-Man's uncle always said, with great power
Comes great responsibility. We can't ignore the environmental impact of combustion, especially when it comes to fossil fuels.
It's a serious issue. So how can we be more responsible in the way we use combustion?
It starts with awareness. Recognizing that every time we drive a car, turn on a light, or use a gas stove, we're engaging with combustion.
And those choices have consequences.
Exactly. By being mindful of our energy consumption and exploring cleaner alternatives, we can lessen our impact.
So it's about making conscious decisions, maybe even changing some of our habits.
Yeah.
What are some things people can do in their daily lives to make a difference?
Oh, there are so many things. For starters, think about how you get around. Could you walk or bike instead of driving for shorter trips?
Or take public transportation.
Absolutely. Carpooling is another great option. And at home, be mindful of your energy use.
Like turning off lights when you leave a room.
Yes. And unplugging electronics when you're not using them. Investing in energy-efficient appliances can make a big difference, too.
Those are all great tips. It's empowering to know that we can take action to create a cleaner future.
We absolutely can. Every little step counts.
Any final thoughts for our listeners as we wrap up this fiery journey?
Stay curious. Keep learning about combustion, explore different fuel options, and consider how your own energy choices contribute to the bigger picture.
Love it. The more we understand about this powerful force, the better equipped we'll be to use it wisely.
Exactly. Knowledge is power.
Well said. And hey, maybe the next time you strike a match or light a candle, you'll see it in a whole new light.
I know I will.
Thanks for joining us on this deep dive into the fascinating world of combustion. We'll catch you next time.
See you then.